Hey everyone, ready to get a little mind-bending today?
Always up for that.
Good, good. Because today we are going deep, really deep into the world of quantum computing.
Yeah, we're talking about way beyond like your laptop or phone.
Exactly. This is the realm where computers they operate on principles that almost sound like science fiction, you know?
Definitely has that sci-fi feel.
It does. It really does. So, to help us navigate this complex world, we're going to be diving into a podcast episode, and the episode is titled Quantum Leap, Exploring the Next Frontier in Computing.
And it features some great experts in the field, right?
It does. It features a quantum physicist, Dr. Sarah Lin, and then also a computer scientist, Dr. David Patel.
Okay, physicist and a computer scientist. So we've got both sides of the equation covered.
Exactly. And what I really liked about this episode is it wasn't just focused on explaining what quantum computing is, but really, trying to answer the question, why is this such a big deal?
Right, right, because it's easy to get lost in the technical details, but we want to know why we should care.
Exactly. So I'm thinking to start off, let's just do like a quantum 101.
Okay, back to basics. Sounds good.
So I'll be honest, I've always found this quantum world a little intimidating, but there was this analogy Dr. Lin used that kind of made it click for me.
Okay, I'm intrigued. Let's hear it.
Okay, so imagine you have a coin, right? And you flip it in the air and it's spinning, and it hasn't landed yet on heads or tails. It's in that in-between state.
I'm picturing it.
Yeah. So that spinning coin, that's kind of like a qubit.
The building block of quantum computing.
Exactly, exactly. So unlike the bits in our everyday computers, which are either 0 or 1, a qubit can be both 0 and 1 at the same time.
Yeah, it's like until you actually stop the coin and look at it, it's potentially both.
It's wild, right?
It is, and that's what they call superposition, and it's one of the things that gives quantum computers their power.
And then there's this whole other concept, entanglement.
Yes, entanglement.
Yeah.
The spooky action at a distance.
That's what Dr. Lin called it. But what does that actually mean? How can two things be linked no matter how far apart they are?
Right, it's mind-boggling. It's like, imagine you have two of these spinning coins, right?
Okay, two coins.
And they're entangled. So if you stop one and see its heads, you instantly know the other one is tails, even if it's like miles away.
No way. Like they're communicating somehow.
Yeah, it's as if there's this invisible connection between them. And this is where quantum computers get really interesting.
Okay, so how does this spooky action actually play into the power of a quantum computer? Like, what can it actually do?
Okay, so think of it like this. Imagine you have a maze, and you want to find the shortest path to the exit.
Okay, I'm picturing it.
Now, a classical computer is basically like trying each path one at a time until it finds the right one.
Oh, I see.
But a quantum computer, using entanglement, it can explore all possible paths simultaneously. It's like sending out these quantum scouts that can check every route at the same time.
Wow, so it's not just about speed. It's a completely different way of tackling the problem, right?
Exactly. It's like instead of searching through the maze, you're sort of experiencing the entire maze all at once.
That's wild. Okay, so we've got the qubits, the superposition, the entanglement. It's a lot to take in, but I think we're starting to get a glimpse of this quantum world.
Yeah, and the best part is we're just getting started. Next, we can talk about the technology, the actual building of these quantum machines, which gets even crazier.
All right, let's do it. So we've got this picture in our minds now of how these quantum computers work, the qubits, the entanglement. But now I want to know, what can we actually do with this stuff? What are the real world applications?
Yeah, that's the big question, right? Like, okay, it's cool in theory, but what can it actually do for us?
Exactly. So where do we even begin?
Well, Dr. Patel, he talked a lot about optimization problems.
Okay, optimization. Like what?
Think of like a delivery truck that has to make a bunch of stops.
Okay.
A classical computer, it has to calculate each possible route one by one, which, can take a long time, especially as the number of stops grows.
Oh, yeah, totally. Like the more stops, the more possible routes there are.
Exactly. And but a quantum computer, using that superposition we talked about, it can essentially evaluate all those routes at the same time.
Oh, wow. So it's like a superpowered GPS.
Kinda, yeah. It can find the most efficient route much faster, saving time, fuel, resources.
That's amazing.
Right.
Dr. Patel also mentioned airlines using it for like flight scheduling and even cities using it to manage traffic flow in real time.
Yeah, there's so much potential to streamline things, make things more efficient.
Make our lives easier.
Exactly, exactly. But you know what really got my attention? It was Dr. Lin's enthusiasm for quantum computing and chemistry.
Oh yeah, she lit up when she talked about that. It was like this whole other level.
Right. She compared the complexity of like simulating molecules at the atomic level to trying to map all the stars in the galaxy with like a handheld calculator.
Yeah, it's just mind-bogglingly complex.
It is, but for quantum computers, it's a much more manageable task.
Okay, so why is that? How can they do that?
Because quantum computers can actually model the interactions between atoms and molecules much, much more efficiently than classical computers.
So what does that mean for us? Like what's the practical implication of that?
Well, imagine designing medications tailored to specific diseases or creating materials with properties we've never even seen before.
That sounds like it's straight out of science fiction.
Right, but it's becoming more and more real,
Hmm.
and it could have huge implications for medicine, energy, even space exploration.
Wait, so this is all pretty amazing stuff. But I have to ask, with such powerful technology, are there any downsides? Like, are there any concerns that we should be aware of?
Yeah, that's a good point. It's not all sunshine and roses.
Yeah.
And Dr. Patel, he did bring up a pretty serious issue. Cryptography?
Cryptography.
Yeah, like
Right.
all our online security, from passwords to financial transactions, they rely on encryption methods that are hard for, our regular computers to break.
Right. Yeah.
But a powerful enough quantum computer, it could potentially crack those codes.
Oh wow, that doesn't sound good. So like, are we all going to get hacked?
Well, it's not an immediate threat, at least not yet. Current quantum computers, they're not powerful enough to do that, but it's definitely something we need to start thinking about, quantum resistant cryptography.
So are there other solutions?
Yeah. Dr. Lin mentioned something called quantum key distribution. It's basically using quantum mechanics to create these ultra-secure communication channels.
Like unbreakable channels.
Theoretically, yeah. Even by a quantum computer. So it's like this double-edged sword, right? Quantum computers could break our current encryption, but they also give us the tools to build even stronger security.
That is kind of mind-blowing.
Right. But it's not just about cryptography. As quantum computing becomes more powerful and more accessible, we're going to have to grapple with a lot of ethical and societal questions too.
Yeah, like who has access to this technology? How do we make sure it's used for good? Those are some pretty big questions.
They are. But for now, let's maybe bring it back down to earth a little and talk about the practical hurdles.
Okay, yeah, good idea. Like what's actually stopping quantum computing from going mainstream? What's holding it back from being as common as, our laptops and smartphones?
Well, Dr. Lin, she highlighted three main barriers: scalability, stability, and cost.
All right, so those sound like some pretty big challenges.
They are, but
Mhm.
but quantum computing is still a really young field, and things are moving incredibly fast. So let's dive into those challenges and the reasons for optimism in the last part of our deep dive.
All right, let's break down those barriers then.
Mhm.
When we talk about scalability in quantum computing, what are we actually talking about? Like, is it just building bigger machines with more qubits?
Well, it's definitely part of it. Right now the most advanced quantum computers, they have a few hundred qubits, but to really unlock the power for things like really complex simulations, like those molecules we were talking about, or to even think about breaking encryption, we'd need systems with thousands, maybe even millions of qubits.
Okay, so it's not just about the number of qubits, right?
Mhm.
It's also about how stable those qubits are.
Exactly. Yeah, remember that decoherence issue we talked about. Any little interference can cause the qubits to lose their quantum state and basically mess up the whole computation.
Right. So it's like this delicate balancing act, right?
Ah.
You need to build these bigger systems, but they also have to be incredibly stable.
Yeah, and that's where the engineering gets really, really challenging. Imagine trying to keep a system with millions of qubits at those ultra low temperatures, near absolute zero.
Yeah, and all of this cutting edge technology, I'm guessing it doesn't come cheap, right?
You got it. The cost of building and maintaining these quantum systems, it's astronomical right now. And not to mention, you need these highly specialized experts to actually run them. It's still a very exclusive club.
So it sounds like we're a ways off from having like a quantum computer in everyone's home.
Yeah, probably not going to see those on Black Friday anytime soon. But Dr. Patel, he was actually quite optimistic about the progress that's being made. He mentioned companies like IBM and Google. They're making some pretty big strides.
Yeah, and I know there are a bunch of startups and research labs out there that are really, really pushing the boundaries.
Exactly. And one thing that I find really exciting is this rise of quantum cloud computing.
Yeah, I remember Dr. Lin talked about that. So instead of needing to like build your own quantum computer, you can basically access one remotely through the internet.
Yeah, it's kind of like the early days of classical computing, when you had those big mainframe computers and only a few people had access to them. But then personal computers came along, the internet exploded, and all of a sudden everyone could tap into that computing power.
So you're saying that quantum cloud computing could kind of democratize access to quantum computers.
Exactly. Yeah, Dr. Lin even mentioned that there are these platforms out there where you can actually run, basic quantum programs right from your laptop. You can use these cloud-based quantum processors. It's pretty cool.
Wow. So even someone like me with zero background in quantum physics, I could potentially get my hands on a quantum program and experiment with it.
Absolutely. It's a great way to kind of get a feel for what this technology can do.
That's incredible. So looking ahead, what can we realistically expect from the future of quantum computing? Will it be like this sudden revolution or more of a gradual evolution?
Both Dr. Lin and Dr. Patel, they emphasize that it's probably not going to be like this overnight revolution. They see it more as this future where quantum computers and classical computers, they work together, kind of like playing to each other's strengths.
So kind of like a hybrid computing model. That makes sense.
Yeah. It's not about one replacing the other. It's about finding the right tool for the job, right? And as quantum computers get more powerful and more accessible, we'll probably see them taking on, these really complex specialized tasks, while our classical computers continue to handle the everyday stuff that we're used to.
It's an amazing time to be alive, to be witnessing like the birth of this whole new era of computing.
I know, it's so cool.
It really is. So as we wrap up this deep dive, what's the one big takeaway you'd want our listeners to walk away with?
I think the most important thing to remember is that quantum computing, it's not just about faster computers. It's about this fundamentally different way of processing information, this way that uses, the strangeness of the quantum world to solve problems that we just can't even touch right now with our current technology.
It's a powerful idea.
Yeah.
It makes you, it sparks the imagination. You start to wonder like what's next? What's possible?
Absolutely. And for our listeners, if you're feeling inspired to learn more, to dig deeper into this, we've included some resources in the show notes, so definitely check those out. Quantum computing might seem like science fiction, but it's becoming more real every day. And it has the potential to really change the world in ways that we can't even imagine right now.
Well said. Well said. Thanks for joining me on this quantum journey.
It was my pleasure.
And to all our listeners out there, keep those minds curious.